Good morning, everyone. My name is Jesriel Casinillo, a BS Agricultural and Biosystems Engineering student from Visayas State University, and I'll be your mathematics lecturer for this review. On this video, we will be reviewing on algebra, exponential, and logarithm. For algebra, we'll be tackling functions, system of linear equations, polynomials, Cartesian plane, and domain. Without further ado, get your pens and paper and do the solving with me. We have question number 1. Which of the following defines a one-to-one function? A, B, C, or D? Before we proceed with the solution, let me introduce to you a function. A function gives you an output for a given input. On another hand, one-to-one function is a branch of function in which the answers never repeat. For every x value or input, there's a unique and only one value of y or output. We can say a function is a one-to-one function if it passed the vertical line test and it passed the horizontal line test. How to do the vertical line test? Doing the vertical line test, you just need to draw vertical lines on the graph, and if drawn lines touches more than one part of the graph, means the function failed the test. For example, this is our drawn lines. As we can see, only one part of the graph has been touched by our lines, thus it passed the vertical line test. And for another example, as you can see, more than one part of the graph has been touched by our lines, this part and this part, thus this graph failed the test. And for the horizontal line test, you just need to draw horizontal lines on the graph, and if drawn lines touches more than one part of the graph, means the function failed the test. For example, this is our horizontal lines, and as we can see, only one part of the graph has been touched by our lines, thus this passed the test. Another example, this is our horizontal lines, and as you can see, two parts of the graph has been touched by our horizontal lines, this part and this part, means this failed the horizontal line test. Let's proceed with our solution. We have the graph of our option A. This is the horizontal line. As you can see, one part of the graph has been touched by our line, thus it passed the vertical line test. And for the horizontal, only one part of the graph has been touched by our lines, thus this passed the horizontal line test. So this graph is a one-to-one function. Let's proceed with our option B for vertical line test. As we can see, only one part of the graph has been touched by our lines, thus it passed our vertical line test. And for the horizontal line test, as you can see, two parts of the graph has been touched by our lines, this part and this part, thus it failed the horizontal line test. And this function is not a one-to-one function. We have our option C, the same as our option B. It passed the vertical line test, but it fails our horizontal line test. Thus, this function is not a one-to-one function. And for our option D, doing the vertical line test, we can see that one part of the graph has been touched by our lines, thus this passed the vertical line test. And for the horizontal line test, two parts of the graph has been touched by our lines, this part and this part, thus it fails the horizontal line test. So, this function is not a one-to-one function. And for our answer, letter A, f of x equals 1/2 x plus 3, because it is the only function that is one-to-one function. And for this item, our final answer is letter A. Let's proceed with our question number 2. Suppose that a plus b equals 2 if the line given by ax plus by equals 16, which passes through 3 and negative 2, what is the value of a and b? A, B, C, or D? This question involves with system of linear equation. System of linear equation consists of two or more linear equations made up of two or more variables, such that all equations in the system are considered simultaneously. For example, 2x plus y equals 8 and x plus y equals 5. And if we say system of linear equation, we have also solution of system of linear equation. It is any ordered pair that satisfies each equation independently. For example, for these equations, we have the solution 3, 2. Let's go try to check if this 3, 2 satisfies these equations. 2 times 3, our value of x, plus 2, our value of y equals 8. Then 2 times 3 equals 6, plus 2 equals 8, then 8 equals 8. So this solution satisfies this equation. And for this equation, 3 plus 2 equals 5, then 3 plus 2 equals 5, 5 equals 5. Thus, this solution satisfies this equation. Let's go with our solution. Given a plus b equals 2 and ax plus by equals 16, where it passes through 3 and negative 2, we have the equations. A plus b equals 2, and we substitute this value of x and y to here. So we have new equation, 3a minus 2b equals 16. We have the solution. Let's solve these equations by substitution method. Let's transform this equation to this one. A equals 2 minus b. Minus b is just transposing this b to other side. And we have here a equals 2 minus b. 3a plus 2b equals 16. And our value of a equals 2 minus b. Then we substitute this a in here. So we have 3 times 2 minus b minus 2b equals 16. Then 6 minus 3b minus 2b equals 16. Then we perform like terms. Negative 3b minus 2b equals 16 minus 6. Negative 3b minus 2b equals negative 5b. 16 minus 6 equals 10. Divide both sides by negative 5. So our answer for b equals negative 2. And we solve for our a equals 2 minus b, then a equals 2 minus negative 2, which is the value of our b. A equals 2 plus 2, then a equals 4. So our final answer, a equals 4 and b equals negative 2. Let's go try to check if these solutions satisfy these equations. So we have 4 plus negative 2 equals 2, 4 minus 2 equals 2, then 2 equals 2. So this solution satisfies this equation. Let's go with this equation. 3a minus 2b equals 16. Then 3 times 4, our value of a, minus 2 times negative 2, our value of b, equals 16. 3 times 4 equals 12. Then negative 2 times negative 2 equals 4, equals 16. 12 plus 4 equals 16. Then 16 equals 16. So this solution satisfies this equation. So for this item, our final answer is letter D. Let's proceed with our question number 3. What should be multiplied to the binomial x minus 2y so that the product is a trinomial? A, B, C, or D? This question involves polynomials. A polynomial is defined as an expression which contains two or more algebraic terms. It is made up of two terms, namely poly, meaning many, and nominal, meaning terms. Terms can be separated by operations plus and minus. Polynomials consist of constants, variables, and exponents. We have also types of polynomials: 1. Monomial, 1 term; 2. Binomial, 2 terms; and 3. Trinomial, 3 terms. Let's proceed with our solution. For our option A, 2y times x minus 2y, we have the product 2xy minus 2y squared. So this is a binomial, 1, 2. And we have our option B, x minus 2y times x minus 2y. We have x squared minus 2xy minus 2xy plus 4y squared. And we perform like terms, so we have the final product, x squared minus 4xy plus 4y squared. So it is a trinomial, 1, 2, and 3. For our option C, x plus 2y times x minus 2y, we have a product x squared minus 2xy plus 2xy minus 4y squared. We perform like terms, we have a final product, x squared minus 4y squared. And it is a binomial, 1, 2. For our option D, x squared plus 2y plus 4y squared times x minus 2y. Then we have a product, x squared minus 2x squared y plus 2xy minus 4y squared plus 4xy squared minus 8y cubed. And it is a polynomial with 6 terms. So our final answer is letter B, x minus 2y, because it produces trinomial when multiplied by the binomial x minus 2y. So for this item, our final answer is letter B. Let's proceed with our question number 4. When graph in the Cartesian plane, which of the following equations passes through quadrant 1? A, B, C, or D? In this question, it involves Cartesian plane. A Cartesian plane divided with 4 quadrants. The x-axis is the horizontal and the y-axis is the vertical. This is our first quadrant. The value of x and y are both positive. This is our second quadrant. The value of x and y is negative and positive respectively. This is our third quadrant. The value of x and y are negative. And this is our fourth quadrant. The value of our x and y is positive and negative respectively. Let's proceed with the solution. So this is the graph of our option A. So the graph passes through quadrant 2 and quadrant 3. For our option B, the graph passes through third quadrant and fourth quadrant. And for our option C, the graph passes through quadrant 1, quadrant 2, and quadrant 4. And for our option D, the graph passes through second quadrant, third quadrant, and fourth quadrant. So our answer is letter C, x plus y minus 2 equals 0, because the graph passes through quadrant 1. So for this item, our final answer is letter C. Let's move on to our last question on algebra. What is the domain of the function defined by f of x equals the square root of x squared minus 1, A, B, C, or D? This question involves domain. As we can say domain, it is the set of all possible x values which will make the function work and will output real y values, not imaginary nor undefined. We have also here the math symbols in sets. First, the parentheses, meaning not included value. Example, parentheses -1, 1, then -1 and 1 is not included. Second, we have the bracket, which means included value. Example, bracket -1 and 1 parentheses, meaning -1 is included value and 1 is not included. And this is for the symbol of our union of sets. We can use the union of sets if there is a gap between the sets of values. This is the symbol for our intersection of sets. Let's proceed with the solution. We let f of x equals 0 in order for us to know the boundaries. The square root of x squared minus 1 equals 0. Then we square both sides. So we have x squared minus 1 equals 0. Then we factor this out. X plus 1 times x minus 1 equals 0. Then our x equals -1 and our x equals 1. This is our boundaries. -1 and 1 as our boundaries. We try to check if the value of x from this side, from -1 to -infinity, is a solution for this function in order for it to work or to output real values, not imaginary or undefined. If x is less than -1, the square root of x squared minus 1, then we'll let x be -2. -2 is still apart from this side. So we substitute this -2 to our x. Then we have square root of -2 squared minus 1. We have square root of 4 minus 1. Then the answer is square root of 3. It is a real number. So all x values that is less than -1 are all solutions of this function because it output a real number. Let's try to check if the x in this region are still a solution for this function to work, for it to output real y values. If x is less than 1 but greater than -1, we have the square root of x squared minus 1 and we let x equals 0. 0 is still apart from this region. So we substitute 0 on our x. We have the square root of 0 squared minus 1. Then we have square root of 0 minus 1. Then the answer is square root of -1, an imaginary number, which means the value of x in this region is not a solution for this function to work because it output an imaginary number value of y. Let's try to check if the values of x from this side is still a solution for this function to work to output a real number. So fx is greater than 1. Then we have square root of x squared minus 1. Then we let x equals 2. 2 is still apart from this side. Then we substitute 2 as our value of x. Square root of 2 squared minus 1. Square root of 4 minus 1. Then we have the answer square root of 3, a real number. Which means all values that is greater than 1 is the solution for this function because it output a real value of y. Then let's go try to check if our -1 and 1 is included from our solution. If we let x be -1, our answer is 0, a real number. And if we let x be +1, our answer is square root of 0, still a real number. So this -1 and 1 is still included in the solution. So to put this in interval notation, the domain is from -1 to -infinity, where 1 is included, thus we put bracket and parentheses for -infinity because we don't know what is the exact value of that -infinity. Union, from 1 to +infinity, 1 is included, thus we put bracket, and for the +infinity, we put parentheses because we don't know what is the exact value of that +infinity. So for this item, our answer is letter A. So we're done with the examples on algebra, then let's go proceed with our next lesson, which is exponential, where we'll be solving exponential equations. Then we have question number 1. What is the value of x in the equation a to the power of x equals 32? A, B, C, or D? In solving exponential equations, first, you must transform the equation to simplest form, then simplify the bases and make the two bases the same in order for us to cancel both bases. And third, solve what is being asked. Given a to the power of x equals 32, then we have the solution. 8 to the power of x equals 32. 8 can be written as 2 to the power of 3 times the exponent x equals 2 to the 5th power. 32 can also be written as 2 to the power of 5. Then we can cancel both bases, which is 2. Then we have the remaining 3x equals 5. And we divide both sides by +3. So the value of our x is 5/3. So for this item, our final answer is letter B. Let's move on to our question number 2. What is the value of x in the equation 1/27 to the power of x plus 1/3 equals 9? A, B, C, or D? Let's proceed with the solution. Given 1/27 to the power of x plus 1/3 equals 9. The solution. First, we must transform our equation to simplest form. 1/27 can be written as 27 to the power of -1 times our exponent, which is x plus 1/3 equals 9. Then 27 equals -x minus 1/3 equals 9. Then 3 to the power of 3, 27 can be written as 3 to the power of 3 times our exponent, which is -x minus 1/3 equals 3 to the power of 2. Our 9 can be written as 3 to the power of 2. Then we can cancel both bases, which is 3. Then we have the remaining 3 times -x minus 1/3 equals 2. Then 3 times -x equals -3x. 3 times -1/3 equals -1 equals 2. Then we perform like terms, -3x equals 2 plus 1. Then we have -3x equals 3. And we divide both sides by -3. So the value for our x is -1. So for this item, our final answer is letter D. X is -1. And that's all for the examples on exponential. And let's go proceed with our last topic, which is logarithm, where we'll be converting from logarithmic form to exponential form and solving logarithmic equations. Let's proceed with our question number 1. What is the value of x in the equation the logarithm of 64 with the base 4 equals x? We have A, B, C, or D. In order for us to know the value of our x, we need to know how to convert the logarithmic form to exponential form. First, the exponential form, we have base, exponent equals answer. 2 to the power of 3 equals 8, where 2 is our base, 3 is our exponent, and 8 is our answer. In converting the exponential form to logarithmic form, just remember the arrangement of the letters from the word base, B, A, S, E, where B is the base, A is the answer, and E is the exponent. And a logarithmic form, we have the logarithm, then base, our B, answer for A, and E for the exponent. Example, the logarithm of 8 with the base 2 equals 3. 2 is the base, 8 is the answer, and 3 is the exponent. Let's proceed with our solution. The logarithm of 64 with the base 4 equals x. Then we convert this logarithmic form to exponential form. So we have 4 to the power of x equals 64. 4 is the base, x is our exponent, and 64 is the answer. So we perform the exponential equation. 4 to the power of x equals 4 to the power of 3 64 can be written as 4 to the power of 3. Then we can cancel both bases, which is 4. So we have 3 as our value of x. So for this item, our final answer is letter C. The value of x is 3. Let's move on to our question number 2. Evaluate the logarithm of 1 over 9 with the base 3. A, negative 2, B, 2, C, negative 3, or D, 3. We have given the logarithm of 1 over 9 with the base 3 equals x. We have the solution. This is the logarithmic form. Then we convert this to exponential form. 3 to the power of x equals 1 over 9. 3 is the base, x is the exponent, and 1 over 9 is the answer. So we perform this exponential equation. Then we have 3 to the power of x equals 9 to the power of negative 1. 1 over 9 can be written as 9 to the power of negative 1. Then we have 3 to the power of x equals 3 to the power of 2 times our exponent negative 1. 9 can be written as 3 to the power of 2. 3 to the power of x equals 3 to the power of negative 2. Then we cancel both bases, which is 3. Then we have x equals negative 2. For this item, our answer is letter A, wherein the logarithm of 1 over 9 with the base 3 is negative 2.